Hey guys, welcome back. Here we are in video number three, talking about how to identify even and odd functions. And this is something that I for sure remember we did back in 1.2. Remember that? We talked about even and odd functions, and we talked about symmetries as well. Well, in this section, they're focused especially on the word even and odd, and they want to focus on the algebraic part, although we did kind of everything last time. So that means we're just, pounding it back into our heads. That's okay. That probably means it would be in the test. And I guess I'm the one who decides because I'm rating the test. So, okay, the box below is exactly what was back in section 1.2. I just copied and pasted this whole thing with the small addition, large font addition, these two equations. So when you're checking even, and we did this last time actually when we were checking in 1.2, but when you're checking if a function is even, you just want to check if I plug in x or if I plug in negative x, do I get the same thing? And if it's always the same numbers that pop out, then you have an even function. If the function itself is unchanged, whether you plug in x or negative x, that's even. On the other hand, if I plug in x and then I plug in negative x and the results are negative of each other, so exactly negative of each other, that means you have an odd function. So that's even and odd. And to check algebraically, you just plug in an x and then you plug in a negative x and see how the function changes. So let's try it now. Questions numbers what? 9 to 13. I have it copied and pasted down here. And you know what? We're going to do what we did last time or before and just write the answers in the scratch area and then erase them after. Because I was thinking about it, I realized it doesn't really make a difference to you whether I keep the answers on my page or not, because you can't really see everything that's outside of the video and the time period that you're watching it. So if you want to go back and see something, you just rewind the video, right? Okay, so number 9. We got, oh, that's ugly. Try again. Number 9, f of x equals 2x plus 4. Let's check f of negative x. Well, let's do this in, let's do our checks in red. So negative x is going to be 2 times, remember, keep it in parentheses, negative x plus 4. That's negative 2x plus 4. So now let's check carefully. Let's look carefully at this. Here, this was a regular 2x, right? Here, I have a negative 2x. Okay, so that's opposite. Here, this was a positive 4. Here is also a positive 4. So one of them is negative, opposite of each other, but one of them is the same. So because I have two different versions, it's not going to be either one, right? It's neither. It's halfway in between being the same and being opposite. So the answer is neither. I want it to all be exactly the same or to be all exactly opposite. So number 9 done. Easy. This is something we should be familiar with, right? So let's just blast through this thing. F of x, this is number 10. 5x cubed minus 2x. But already before I even do this question, I know the answer because look at the powers. It's a polynomial, right? Power of 3, which is an odd number. And then x is just a hidden 1, which is an odd number. So I've got two odd powered things. That means it's going to be an odd function. That's even where kind of the intuition behind the name came from, with an odd function. But let's check anyway, just to make sure our thinking is correct. F of negative x would be 5 negative x to the third power minus 2 times negative x. Negative x to the third power is going to be negative of x cubed because 3 negatives make a negative. Multiplied by 5, right? And then negative 2 times negative x is a plus 2x, which is negative 5x cubed plus 2x. You know, as I'm writing this, guys, this is a good reminder for us. Remember to practice as you're doing your classwork, writing out the full expression. I know some of you guys are doing a good job with it, looking at your classwork, and some of us not so much. So just get into the habit of showing your work, because this is going to be important for you getting full credit on an exam situation. I know when you do your MyLab math homework, it doesn't matter because you don't show your work for that. But we need to see the thought process. Thought process is actually more important. The plus side of that is even if you end up with the wrong answer in the end, as long as I can track your thinking, then I can usually give you at least partial, maybe even sometimes most of the credit. Okay, coming back to our question though, guys. Here, this was a positive 5x cubed, right? There, this is a negative 5x cubed. Here, this is a negative 2x. Here, this is a positive 2x. So we see that they're exactly opposite of each other, which makes this an odd function. Opposite of each other, meaning that one is the negative of the other, right? Okay. Let's delete that. Number 10, done. Okay, on to number 11. F of x equals absolute value of x minus 5 plus 4. Okay, before I do this question, I already have an intuition what's going to be, and I'm suspecting it's going to be neither. Why do I suspect that? Because I know what an absolute value function looks like, right? It looks something like this, right? I wonder if I can grab this thing. Oh, yeah. Okay, so this is an absolute value function, right? Now, what does this minus 5 close to the x do? Remember, minus numbers close to the x, that moves things to the right. So that's going to move 5 to the right. And then plus numbers at the end, that moves things up. So it's going to be 4 up. So you're going to have this new starting position right there. And basically right here, that means, yeah. So that's going to be your new picture. And if I was to reflect this over the y-axis, am I going to land back on myself? No, I'm going to end up like somewhere over here, right? That's totally different from my original, so it cannot be even. Now, what if I rotate this guy? If I rotate it 180 degrees, it's going to look something like this, right? And is that going to land back on itself? The answer is no, so it's not odd either. It doesn't have either type of symmetry. Okay, that's visually what's going on, but let's confirm algebraically now. By algebraically, I mean, let's look at this equation. So I'm going to stuck in one negative x, yeah? Except, you know, when you input a negative x here, you get the absolute value of negative x plus 5, right? I'm sorry. I meant minus 5. Plus 4. And just look at it like this, it's kind of hard to see what's going on. So how do we deal with absolute values? I'm going to put these guys side to side. Well, the way that we deal with absolute values is we think of them as two cases. So two cases. If this inside thing is positive, then it's going to be the original value. But if this inside thing is negative, then you're going to take the opposite of it to make it be positive overall. So what I mean by that is, look at this thing. If x is 5, it's 0, right? So if x is bigger than 5, bigger or equal to 5, then f of x is going to be equal to just the original x minus 5 plus 4. And, oh, you know, this is not a good color choice here. I'm sorry, guys. I'm sorry I waste our time here. Let me do that again. Because I was using red on the right already, yeah? So what was I saying? I'm going to break it into two cases. X bigger than or equal to 5 and x less than 5. If x is bigger than or equal to 5, then f of x is equal to just the original function x minus 5 plus 4, right? But if it's minus less than 5, that's going to make this inside thing negative, right? And if it's negative, the absolute value is going to switch the sign to be positive. So then f of x would be, it would be the opposite of x minus 5 and then plus 4. Okay, now I'm just going to check one of these things and match it up to see if it, you know, if it satisfies the even or odd definition here. So let's just pick one of these. I'm going to pick greater than or equal to 5. Okay, so what happens if x is greater than or equal to 5 here? Well, I'm going to have negative a number, right? Negative 5 or negative 6 or negative 7 or something like this, right? And then I have minus 5. That's going to make it overall a negative value. But an absolute value has to switch it to be positive. So that means for x bigger than or equal to 5, f of negative x is going to be equal to the opposite of negative x minus 5 plus 4. Right? So what is that? Okay. F of negative x is equal to negative distributes, right? So I have positive x plus 5 plus 4. So f of negative x is equal to x plus 9. What was my original x, f of x? Okay, for x greater than or equal to 5, let's do that same kind of simplification here. This guy would have been x minus 5 plus 4 is x minus 1. Right? X minus 1. X minus 1 versus x plus 9. Are those the same? No, so it's not even. Are they opposite of each other? No, so it's not odd. So it's neither. Now, if I really wanted to, I could also do the same kind of check for when x is less than 5 and do like another separate case. But it's not necessary because I've already determined that these guys do not match up, right? So they already don't match up. If they don't match up in one spot, then they're not matched up overall. Okay, that one is probably the hardest question here, guys. And yeah, the hardest question here because you have to deal with the absolute values by cases. Sorry, there's construction going on around here, guys. You can hear that pounding. My apologies. But this video is going to end in 2 more questions anyway. F of x is 1 over x squared plus 6. Looks even to me. Because this is an even function. And if you have just a constant you can think of as x to the 0, which is an even number. 0 is even, right? But let's check. What would f of negative x be? This would be 1 over negative x squared plus 6, which is 1 over negative x times negative x is just x squared plus 6. So f of x was 1 over x squared plus 6. Let's do this. F of negative x is 1 over x squared plus 6. They're the same. And since they're the same, that means even. Very nice. That was easy. Done that one. One more for this video. Okay, last one. Let's do a celebratory color here. It's hard to see. Let's do this one. 13. F of x equals x cubed plus 2. This is just like what we did last class, isn't it? Not last class, I mean back in section 1.2. Okay, you know, my intuition's not very good for this one, so I'm just going to try to see what happens, okay? Let's just see what happens. F of negative x. I don't like the way this has been looking. I look like my handwriting is that of a little kid's. F of negative x, it's going to be negative x cubed plus 2 times negative x, right? Use our parentheses to effect here. 2 times negative x to the 5th minus 3 times negative x. Okay, let's see what pops out. The top, negative x to the cubed, is going to be negative x cubed. 2 times negative x is going to be minus 2x. The bottom, I have 2 times negative x to the 5th is going to be negative 2x to the 5th. Negative 3 times negative x is going to be plus 3x. Okay, earlier you guys saw me use a little trick where I was just trying to, you know, compare all the signs. That's not going to work in this case because I have a fraction. So you got to do some simplification before we can accurately compare. And so here's what we want to do. We want to try to factor out whatever negatives we can, try to simplify what we can. I'm going to do the next step in black so I don't get mixed up with the previous one. So check this out, guys. See how these are both negative? I can actually factor out one of those negatives and make this negative on the outside, x cubed plus 2x. Okay, what about the bottom? Same kind of deal. Same kind of deal. I'm gonna factor out again. Why am I doing that? Just to make this front thing positive. So this is gonna be a negative of a 2x minus 3x. Then it'll be easier to compare. Okay, so now you see that you have a negative on the top and a negative on the bottom, right? That means I should be able to cancel those things out. That's going to give me x cubed plus 2x over 2x minus 3x. Okay, now let's... Oh, I'm sorry. I lost the 5 along the way. Oops. This is to the 5th power here. This is to the 5th power here, yeah. Okay, so I have x cubed plus 2x on the top and 2x to the 5th minus 3x on the bottom. So now let's compare, and you guys probably see what's happening here already. X cubed plus 2x on the top. And then 2x to the 5th minus 3x on the bottom. 2x to the 5th minus 3x on the bottom. So now it matches up perfectly, right? f of x and f of negative x both were the same, which means we have an even function on our hands. Even. Done. Just kind of recapping, guys. Small tip here. Make sure you continue. At this point, it wasn't obvious, right? That was the same. Make sure you continue the algebra until you simplify all the way, and then you can compare more accurately. All right. See ya in the next one.